Hi everyone, my name is Vincent Claveau. I'm about to present you very briefly the text and network approaches that we have developed for this fake news detection challenge. Concerning the text subtask, we have submitted 4 runs. They all have a common basis. First, we do not use any external data, so we rely only on the tweets, provided that was still available online. And all our runs are based on a pre-trained transformer model, namely the Roberta large model. For the first one, we have trained a SVM whose input is the pre-trained embedding from Roberta. For the second one, we have fine-tuned the Roberta model with a simple linear classification layer. Besides these two pretty usual approaches, we wanted to investigate the interest of data augmentation. So we have trained a generative model, namely GPT-2, for each class to be able to generate artificial example, so for each class. The point is that there are many important hyperparameters to tune, which was not properly done due to the lack of time. On this slide, you can see two examples of tweets that were artificially generated by the model trained for the 5G class. So this is pretty convincing, but there are also a lot of tweets that just repeat the original ones, so we have a lot of overfitting. And here are the results for our runs. I indicate several scores with cross-validation and the official MCC score obtained on the test set. So the first thing to notice is that off-the-shelf Roberta fine-tuned with a simple linear classification layer performs well. Non-fine-tuned Roberta model with the SVM yield lower result for any score, and this was expected. But what is disappointing here is that our augmented dataset with the generated tweet does not bring any better results. We need to further investigate why, but this is certainly caused by overfitting the generative model, and we really needed to find a way to set the hyperparameters, or maybe there was simply not enough data to train such generative model. And now let's keep to the approach that we propose for the network-based detection. Here we have investigated two simple ideas. The first one is to try to exploit the fact that a user that has already shared a fake news is prone to share other ones. So we simply compute a kind of reputation score for each user based on the news he shared and his neighbor's reputation. And this is implemented as a page rank algorithm. The second approach relies on the idea that fake news do not propagate in social network as other news. So we look at how many followers are exposed to the news, at which speed, and so on. We use standard classifiers for these two set of features. And here are the results. As one can see, the reputation yields the best result, yet the propagation results are not so bad given the simplicity of the feature used. We have also tried to combine both, but it did not improve the result at all. And that's it. There are still many things to test and try for this task, and we will go on working with that. Thanks for listening.